wabarakatuh. Good day everyone. My name is Putri Yustika Sari and my friends Najla, Rizani, Fahlevi. We are from Group 1. We will bring materials about concentration of solution. We are from Bilingual Chemistry Education 2018 State University of Medan. So, before we talk about concentration and solution, we must know the two basic components of solution. The two basic components of solution there are solute and solvent. And the definition of a solute. A solute is the material present in the smaller amount in the solution. And a solvent is the material present in the larger amount in the solution. So, I will give you an example. If you have a salt and you have water, so the salt is a solute and the water is a solvent. And if you added a salt to the water, so it's become a salt solution.
Solution. A solution is a homogeneous mixture of two or more substances. A solution may exist as any base. A solution consists of a solid and a solvent. The simple definition: a solution is a special type of homogeneous mixture composed of two or more substances. Example: the solute is sugar and the solvent is water. Sugar in water is dissolved, so that it's called solution. Next, concentration. The concentration of a solution is a measure of the amount of solid that has been dissolved in a given amount of solvent or solution. With the last example, the amount of solid is the amount of the sugar, and the amount of the solvent is the amount of the water. A concentrated solution is one that has a relatively large amount of dissolved solid. We can see in the picture, the more clearer the color is more dilute than the dark one. So, in calculation of the concentration, we must know about the mole. And the calculation of the mole is a gram of the solid divided with relative mass of the molecule.
Next topic, we talk about concentration unit. In concentration unit, in physics, there are mass percent, volume percent, density, and parts per million or ppm. Concentration unit in chemistry, there are molarity, molality, normality, and mole fraction. So I will explain you the concentration unit in physics, and my friend Najla will explain you the concentration unit in chemistry. First is mass percent. Mass percentage is one way of representing the concentration of an element in a compound or a component in a mixture. Solution can also be represented as percent of solute in a specific mass of solution. So, for calculating mass percent composition, there are the formula. Mass percent is mass of element in 1 mole of the compound divided by molar mass of the compound times by 100%. For the simple formula, mass percent is mass of solute divided by mass of solution times by 100%. For the example 1, if a solution that has a mass of 800 grams contains 20 grams of sodium chloride, what is the concentration using percent by mass? From the example, we know the mass of solution is 800 grams and the mass of solute is 20 grams. And the X is mass percent of sodium chloride. For the answer, mass percent of sodium chloride is mass of sodium chloride, that is 20 grams, divided by mass of solution, that is 800 grams, times by 100%. So we know the mass percent of sodium chloride is 2.5%. For the example 2 of mass percent, how many grams of sodium bromide are in 200 grams of solution, that is 15% sodium bromide by mass? From the example, we know mass of solution is 200 grams, mass percent of sodium bromide is 15%. So the X is mass of solute. For the answer, for searching mass of sodium bromide, you just can multiply the mass percent of sodium bromide with mass of solution and divide it by 100%. Mass of solution is, that is 200 grams, times by mass percent of sodium bromide, that is 15%, divided by 100%. So mass of sodium bromide is 30 grams. For the example 2 of mass percent, how many grams of sodium bromide are in 200 grams of solution, that is 15% sodium bromide by mass? From the example, we know mass of solution is 200 grams, mass percent of sodium bromide is 15%. So the X is mass of solute. For the answer, you just can multiply the mass of solution with mass percent of sodium bromide and divide it by 100%. So for mass of sodium bromide is mass of solution, that is 200 grams, times by mass percent of sodium bromide, that is 15%, and divided by 100%. So mass of sodium bromide is 30 grams. For the next concentration unit in physics, that is volume percent. For the definition, volume percentage is a measure of the concentration of a substance in a solution. Volume percent is the concentration of a certain solute measured by volume in a solution. For the formula of volume percent is volume of solute divided by volume of solution times by 100%. For the example of volume percent, if a 10 milliliters of propanol is diluted with water to a total solution volume 200 milliliter, what is the percent of volume of propanol in the solution? From the example, we know the volume of solution is 200 milliliters, volume of solute is 10 milliliters, and we ask volume percent of propanol. For the answer, volume percent of propanol is volume of propanol divided by volume of solution times by 100%. Volume of propanol, that is 10 milliliters, divided by volume of solution, that is 200 milliliters, times by 100%. So volume percent of propanol is 5%. Okay, for the next concentration unit in physics is parts per million or ppm. The definition of ppm, parts per million, is the number of units of a mass of a contaminant per million unit of total mass. Part per million is one part of a solute per million parts of solution. For the formula, first ppm in mass. Mass solute divided by mass solution times by 10 degrees C. For ppm in volume, volume per solute divided by volume solution times by 10 degrees C, or ppm in mass and volume. That is mass solute divided by volume solution times by 10 degrees C. For the example of ppm, in the United States and Canada, drinking water cannot contain more than 5 times 10 degree mean per milligram of mercury per 1 times 10 degree 3 milligram of sample solution. In parts per million, what would that be? From the example, we know mass of sample solution is 1 times 10 degree 3 milligrams and mass of solute 5 times 10 degree mean per milligram, and the answer for ppm. We can answer the ppm is mass of mercury divided by mass of sample solution times 10 degree C. For the mass of mercury is 5 times 10 degree mean per milligrams divided by mass of solution, that is 1 times 10 degree 3 milligrams times by 10 degree C. For the value of ppm is 0.5 ppm. Next, the last concentration unit in physics is density. Density is a measure of mass per volume. The average density of an object equals its total mass divided by its total volume. Density states the amount of substance in 1 milliliter of solution. That is the formula of density. Density is mass per volume. Where the mass unit is grams and mass volume unit is milliliter. For example of density, calculate the density in grams per milliliter of 30 milliliters of solution that mass 120 grams. For the example, we know the mass of solution is 120 grams per volume of solution is 30 milliliters, and the X is for density. For the answer, density is mass of solution divided by volume of solution. So, the volume of solution is 120 grams divided by volume of solution, that is 30 milliliter. So, the density is 4 grams per milliliter. That's all from my material. Thank you. Will be next by my friends.
Molarity. The molarity of a solution is the number of mole of solute dissolved in 1 liter of solution. To calculate the molarity of a solution, you divide the mole of the solute by the volume of the solute expressed in liter. So in the slide, you can see there is the triangle. The triangle is made here to you to understand easily how to calculate the molarity. And then there is the calculation here. Molarity is the mole divided with the volume of the solution. And then if we make the mole with the last calculation. So the molarity is gram of the solid divided with the mass molecule relative times with 1000 divided with the volume of the solution in milliliter. Example: what is the molarity of a solution prepared by dissolving 15 grams of sodium hydroxide in enough water to make a total of 225 ml of solution? We will answer it together with the calculation. In molarity is the gram of the solid divided with a mass molecule relative times with 1000 divided of the volume of the solution in milliliter. So we changed it with the data that we have in the question. The gram, we put it 15 gram, and the mass molecular relative of the sodium hydroxide is 40 times with 1000 divided 225 milliliter, and we will get 1.6 molar. Molarity. The molarity of a solution is the mole of solid divided by the kilograms of solvent. While molarity is based on the liter of solution, molarity is based on the kilogram of the solvent. And there is the triangle again to make sure you can easy to understand the calculation. In here, molarity is the small m, is mole divided with the kilogram of the solvent. The example of the molarity. Can read the question? And in this question, they give the density of the water. Why they give it? So we will answer it. First thing first, we have to find the mole of the sugar cube with the calculation of gram sugar cube slash mass molecule relative of the sugar cube. And then we have it, 4/342. How we find the 342? It's from the sucrose. We can see in the question, C12H22O11. Answer it is 0.0117. Then we have to find the mass of the water. How to find the mass of the water? Mass is density of the water times with the volume of the solvent. There we have it, 0.975 times with 350. And then 341 times 25 gram. And we have to change it to kilograms based on the calculation for the molarity. So have to find the molarity. And then the molarity is mole of the solution divided with the kilograms of the solvent. Then we put the value of it, and then the answer is 0.034 mole/kilogram. Normality. Normality of a solution is the gram equivalent weight of a solute per liter of solution. It may also be called equivalent concentration. How to calculate it? Normality is called N, is gram of equivalent solute slash volume of the solid in the liter. And then weight of slash equivalent weight, equivalent in the molar mass slash N. And in here is the valence of ion. Can see example of sodium Na plus. The plus in the ions of the sodium is 1, so the N is 1. Example for the normality. Calculate the normality of sodium hydroxide solution from by dissolving 2 grams sodium hydroxide to make 250 milliliter solution. We answer it with the calculation before. N is gram of solid divided with equivalent number times 1000 per milliliter of the solution. And the equivalent, we can know it from mass molecular relative slash N. And in here is the valence of the ions. Like I said before, the N of sodium is 1 because sodium is Na plus. Na plus. So that's why the N is 1. So we can put it here. The gram is 2, the MR is 40, the N is 1, the 1000, and the milliliter is 250. And then we have it, 0.2 normality. Next, mole fraction. Mole fraction is the ratio of the mole of one substance in the mixture to total number of the mole of all substance. For a mixture of two substances, A and B, the mole fraction of each would be written as follows. XA is mole A slash mole A plus mole B. For the XB is mole B slash mole A plus mole B. Mole fraction is useful to quantity of the analyzing gas mixture in conjunction of Dalton law of partial pressure. And there is the calculation you can see in the slide. Next, this calculation we will answer our example. Example for the mole fraction. You can see the question. The question so that calculate the Dalton's law of partial pressure. First thing first, we have to find the mole fraction of the hydrogen gas. This is 1 mole of the hydrogen gas divided with 1 mole plus 3 mole of helium gas. And then the answer is 0.25. So how to find the helium gas? Same as before, but the up one is a 3 mole. And then divided with 1 plus 3, and the answer is 0.75. How to find the pressure total? The pressure of the hydrogen gas and the pressure of the helium gas is given in the question. So there's the answer. 600 plus 1800 is 2400. The calculation of the Dalton law is pressure of hydrogen gas is the mole fraction of hydrogen gas times with pressure total, and for the helium, fraction of helium gas times with pressure total. And then you just put the value that we have before, and there we have it. This is it. This is one of the application of the mole fraction. So that's all for the calculation of the solution. Thank you for watching. Bye.